Today we are joined by Dr. Greg McDonald from the University of Florida. Dr. McDonald will discuss the biology, ecology, and management of Cogongrass in the southeastern U.S. This webinar is designed to help woodland owners, foresters, researchers, natural resource managers, and concerned citizens to learn how to identify Cogongrass and discuss management options. The title of Dr. McDonald's webinar is Cogongrass Management, Past, Present, and Future. With that, I'll turn it over to Dr. McDonald.
All righty. Well, thank you very much, and thank you for having me today to talk about Cogongrass. I've been working with Cogongrass for probably upwards of 30 years, in and out with graduate school, and since I've been back at the University of Florida, about 15, almost 20 years now. So what I'm going to do is I'm going to talk to you a little bit about some research that we've been doing on the management of Cogongrass. In the beginning, I'm going to go through some biology factors with respect to how to identify it, kind of its adaptation, why it's a big issue for us here in the southeast, and also get into what we have for management techniques, go through a few studies in which we've tested some other materials and other techniques for Cogongrass, and then I want to finish up on where I think we are with respect to Cogongrass management, with respect to seeds, and maybe some issues that we're right on the bubble with that we need to kind of address before things get out of hand. So let me move to the next slide here. And by way of introduction, Cogongrass is not native to the U.S. There's been a lot of contradictions, but I think in the last 15 or so years, we've pretty much figured out that it is native to that Southeast Asia area. That would be Indonesia, Malaysia, parts of Japan, and the greater continent of Asia. It infests nearly 500 million acres worldwide. It is a major problem in every continent with the exception of Antarctica. It is pretty much limited to tropical and subtropical areas, with limited spread to northern temperate regions. However, we do have some concerns that it might be trying to move north. We're not sure if why the reasons that is, but the fact that it does survive in areas with some significant frost is a little concerning, and we're trying to look at reasons why that might be the case. Its first appearance into the U.S. Was in Grand Bay, Alabama. It came over as an accidental packing grape material from some oranges in 1912, 1911. We're still not quite sure on which year that is, but it doesn't really matter for the standpoint of the fact that we have it now. It was also intentionally introduced into Mississippi by the USDA as a possible forage in 1921. It was then subsequently taken to Florida and introduced there, and also into Texas and Louisiana. The Louisiana and Texas introductions died out, but the Florida introduction maintained itself at the Brooksville station. It was evaluated for about 10 years. Ranchers came into the research center and took possible forage rhizome material back to their individual farms to test, but after about 10 or 15 years, it was found to have very little economic forage benefit. It was a very aggressively growing grass, but it didn't have the forage content compared to some of our traditionally used forage grasses. Unfortunately, it just continued to thrive and spread, and now we have the issue in the southeastern United States with several 100,000 acres of area that has been infested. Now, what I'd like to do now is spend a couple of slides talking about how to identify Cogongrass. Now, one of the easiest ways to identify Cogongrass is its leaf color. It has a tendency to have more of a lighter lime green type color. The other thing is, if you look at the leaf blade, you can see that the midrib that I'm pointing to here is off-center. And this is very characteristic of Cogongrass, having that off-center midrib, which is characteristic compared to our other grasses. The other thing you'll find out with respect to the leaves is almost all of the above ground material is leaf material. Cogongrass does not put up any kind of a shoot whatsoever unless you start to see that fluffy white seed head that is basically the only stem that comes above the ground. Now, one of the things about the seeds that are being produced, for the most part, Cogongrass does not produce viable seeds. And we'll talk about this later on in the webinar, but the seeds that are produced are most often sterile because of the fact that Cogongrass will only outcross. So it has to see a population that was introduced from another seed source. And since most all of the Cogongrass that was introduced into the U.S. was from rhizome material, all of those populations are considered to be clonal. So we have very little seed production, at least initially. We thought for many, many years there wasn't any seeds. But at the end of this, I'll talk to you a little bit about some concerns that we have in this area. Now, one of the other things I'd like to mention with respect to flowering is that Cogongrass generally flowers in the springtime. So once the temperatures begin to warm up, Cogongrass will readily flower. However, it's not limited to springtime seasons. Any kind of a stress, mowing, fire will also induce flowering, particularly in some of our older populations. Now, as I mentioned before, almost all of the above ground leaf material is leaves. These can extend 2 to 6 feet tall, depending on the conditions, moisture, fertility, things like that. But the big issue is the below ground biomass. If we look at that picture on the right, you can see the extensive rhizome mass that this plant produces. And in areas of full sunlight, where it's growing in full sunlight conditions, you can see upwards of 60% of the total plant biomass being below ground in the rhizomes. And this makes it very difficult to control because of the fact that we have such a very low shoot to rhizome ratio, where you have a limited amount of above ground biomass to apply any kind of a management technique to translocate and get down into that rhizome base. The other thing that this rhizome mass does is it provides a considerable amount of energy and resilience to the plant, which allows it to readily regrow, and therefore management techniques are much more difficult because of this below ground rhizome biomass. And remember, rhizomes are basically underground shoot tissue, and they have multiple nodes in which they can start and regenerate new leaf material. Now, a couple of the special adaptations that we see with respect to Cogongrass is, in most cases where it's introduced, it forms a very large monoculture, which means it's the only thing there. It does not play well with others. It does not integrate well with other crops or any other native species. It has a tendency to dominate and become just a single large stand of Cogongrass. The other thing is it has the ability to be successful in low light environments. Unlike many tropical grasses, this grass has the ability to survive in about 5% sunlight. So it can maintain itself even under some fairly dense cover, which in a lot of our southeastern ecosystems, we have a lot of pine. It readily adapts and can survive very well underneath pine. It is fire adapted. It is also drought tolerant. And if we look at a lot of our systems, they're pyrogenic systems that like to be burned. We also have various times throughout the year in which we have a high amount of drought. Cogongrass is well adapted to fire. It is well adapted to drought. One of the reasons it's adapted to fire is the fact that, and drought, is once again this very large rhizome biomass, which allows the leaf material to be removed, but you still have enough energy in those below ground stems to regenerate. And those below ground stems have special adaptations to conserve water and therefore can persist throughout a dry season. Now what I'd like to do is switch away from the biology and why Cogon is such a bad problem to talk about some methods of management. Now, before we get into our traditional management methods, I would like to go ahead and cover all the methods of weed management together as an integrated approach. And this would be prevention, cultural, biological, mechanical, and chemical. Those are the 5 methods of weed management for any target species. And for Cogongrass, we're going to talk about, first of all, prevention and cultural. Prevention, reduce any sources of, quote, inoculation. Make sure your equipment is clean. Make sure your mowers, any kind of a disc, if you're cutting fire breaks, or anything of the nature, logging equipment. If you have an area where there's Cogongrass, make sure you're not dragging it into new uninfested areas. From a seedling standpoint, we've done some research to show that if you have fairly decent cover, the seedlings generally don't establish and recruit. So good cover is going to help on that end. And then also maintaining a good suite of native desirable species is best to try to keep Cogon out. But the big ones are keeping your equipment clean, not allowing those rhizomes or other pieces of potential propagules to be spread into a non-infested area. From a biological standpoint, we have several people that have been looking at biocontrol, but there has been limited success so far. One of the reasons could be if you go back to its native range in Southeast Asia, there are very few things that attack Cogongrass in its native environment. There are a few isolated disease organisms, some pathogens that have been isolated on Cogongrass, but none to date show a very effective amount of control with respect to giving us a measurable amount of impact. As I mentioned, it was brought in as a forage, but grazing is probably not going to be feasible, at least from a production standpoint, because the weight gain on cattle or other foraging animals is just not there compared to our introduced grasses, Bahia grass and Bermuda grass in particular. There's some limited insect pests, but even in the native range, they don't do a considerable amount of damage. So we're not seeing it at this point. There may be some out there. We've got folks that are doing a lot of searches throughout the world looking for things that eat Cogongrass, but to date we don't have anything substantial to be able to integrate into an overall plan. Now, mechanical control, if you have large areas where you can till the soil, basically put it into like an agricultural type of situation, mechanical control will provide very good control. The issue here is it's got to be repeated and it's got to be aggressive. So lots of areas where we have Cogongrass here in Florida is abandoned agricultural land that was marginal land. It was put into agricultural production. The landowner, rather than continue to lease this out, will often donate this either to a county, to a city, sometimes to one of the park services, and they're left with a field that's marginal. They're left with a field that is kind of in a degraded agricultural state, and then we have Cogongrass come in. In those situations, we often recommend going in and just doing some aggressive tillage. You either deep plow or disc several times throughout the season, you desiccate those rhizomes, you cut them up, you allow them to resprout, and you continue to work the soil to exhaust those food reserves. We generally have to go down to a depth of at least 12 inches. We recommend a very heavy-duty, aggressive disking. It does a good job if you keep up with it. So if you continue to do this every couple of months as Cogongrass begins to resprout, that's fine. It does a really good job. However, a single disking or a single mechanical tillage operation really won't do us much good. As a matter of fact, we've had a lot of studies where it actually makes things worse because it allows Cogongrass to resprout much more aggressively. We get more shoot biomass, and then the native species just cannot rebound as quickly as Cogongrass. So mechanical is very good. We often integrate it, but don't rely on a single pass alone because it just won't work. Burning provides a great amount of relief from the standpoint of getting that above ground leaf biomass all off of the surface. One of the things we find with Cogongrass is the fact that it will keep dead shoots above ground intermingled with the green shoots, and that's to maintain a fuel load, to maintain burning, because how Cogongrass maintains its dominance is by burning. It eliminates any above ground shrubs, any seedling trees that are trying to come in. Because of the tremendous amount of fuel, you have very high heat, you have damaging temperatures much further up in the air compared to a normal understory burn. And you can see in this picture right here the very aggressive burning and flames that come up from Cogongrass. And if anybody of you have ever burned Cogon, you know what I'm talking about here. But it does a good job in kind of leveling the playing field. We will see regrowth within a week. You target the regrowth then with a chemical application. It does a better job because of the fact you've removed all that above ground dead material that basically does you no good. The next slide here is kind of an old picture. It's basically taken out of a 1988 thesis from the University of Florida by Tommy Willard. And what you'll see in these two circles are glyphosate and Imazapyr. And we all know that glyphosate and Imazapyr are those two products that we've used for the last several years for Cogongrass control. And if we look, we can see glyphosate all the way over, 86% control. We see glyphosate, Imazapyr, 96 all the way up to 89% control. If we look at the rates for glyphosate, that's the highest labeled rate. Almost 4.5 or 5 pounds of active ingredient, or almost a gallon to the acre. If we go down to Imazapyr, basically that rate that gives you 88%, that is the maximum labeled rate that we still use today. The next thing I'd like to do is we've talked about the fact that we've been using glyphosate and Imazapyr for basically decades, and that work was done a long time ago. Unfortunately, we're still using the same kind of products, but I'd like to point out kind of the effectiveness as a function of application timing. Now, if we look at our Imazapyr on top, we can basically see that Imazapyr runs from about 70 to almost 90% control in November, and this is 12 months after we've done the initial application. So we would have applied it in November, came back that next November and got 87% control. In May, we would have applied it in May and then came back the following May, and we see about 69% control. Let's drop down to glyphosate. If we look at glyphosate, we're seeing less control, which we often see. We're also seeing 63% in November, but go all the way out to May, we can see very, very low percentage of control in May. So what that tells us is that glyphosate is much more dependent on time of year for effectiveness. So if you're able to spray in the late fall, when we characteristically try to recommend to control Cogongrass, glyphosate is going to give you much better control from a fall application as compared to all other times of the year. Imazapyr is not as dependent on time of year, and the reason that is because Imazapyr has soil activity. So as that Cogongrass begins to regrow, it intercepts Imazapyr in the soil. As I mentioned before, we talked about the rhizomes, and we also talked from the biology standpoint the fact that Cogongrass has the ability to survive under very low light conditions. One of the things that I'd like to point out in this table right here is we used Imazapyr and we used glyphosate, and we sprayed it on Cogongrass under different light levels. So we sprayed glyphosate at 3% sunlight, so Cogongrass growing under very, very little light, a little bit more light at 9%, a third sunlight at 30%, and 2/3 sunlight at about 60%. what I'd like you to do is look at glyphosate and the amount of herbicide that shows up in the shoots versus the roots. So for glyphosate, 5% ends up in the shoots at very low light, very little down in the roots. But once you get to 9%, 30 and 60%, an equal distribution between shoots and roots. Okay? This also occurs for Imazapyr. Almost none getting down to the roots at very low light, but a fairly equal distribution when we look at 9, 30, or 60%. So what does that tell us? One, it tells us that Cogongrass, basically, when you get under very low light conditions, it does not move any herbicide below ground. That's why in some cases where we see difficult control under shaded, it's the fact that the plant itself is not moving any material down to the root system. The other thing it tells us is the fact that even as low as 9%, Cogongrass is gaining enough photosynthase, generating enough carbon to be able to move it down into the rhizomes, even at 9%. So at 9%, it's still maintaining a very aggressive rhizome base. So this is very uncharacteristic of a lot of tropical species, but unfortunately for us, Cogongrass has the ability to do that under fairly low light conditions. Now, if we integrate all of these things together from a chemical control standpoint, what we generally recommend is either glyphosate or Imazapyr at the maximum labeled rate for Cogongrass or other, depending on your area, natural areas, things like that. So we recommend you go right to the highest rate for Cogongrass control. If you're using spot treatments, of course, 2 to 3% with glyphosate, Imazapyr, 0.5 to 1%. Some folks will use some combinations of those two. We always use a surfactant at 0.25%, which equilibrates right around to 10 mils per gallon. And with Imazapyr, because of the soil activity, you need to make sure that you're not in areas where you have the roots of sensitive species that could take up the herbicide and cause off-target damage. I'd like to point out here in this slide, if we look at the dead patch of Cogongrass that I'm running my pointer around, we can see where Cogongrass was sprayed. This was with Imazapyr. The other thing I'd like to point out is that tree is dead, that tree is dead, that tree is dead, that one, and this one over here, due to the soil activity of Imazapyr. Imazapyr is very effective in Cogongrass, but it also has a considerable amount of soil activity and can cause problems. So we need to be careful when we're using this product around sensitive species. Next, what I'd like to do is talk to you a little bit about some studies that we've done on Cogongrass, looking at some alternative chemistries for Cogongrass control. These were all conducted on an abandoned agricultural field down in Cheeto Branch. It was an old ag field that was given to Hillsborough County. It's right outside of Tampa, to the west and to the east just a little bit. All the Cogongrass had been burned, and it was about 2 to 3 feet at the time we did the treatments. All treatments were done in the fall, and unless otherwise specified, we used a typical non-ionic surfactant at that 0.25% volume per volume ratio. And we performed visual ratings, and most of these are all going to be at 12 months after application. So 1 year later, after we sprayed, we went back and looked, and we find that looking at it 12 months later gives us the best snapshot of how things are going to work. Lots of times we'll see great burn down from things at 3 months, but the true tale of how it's going to work is always shown at 12 months later. So one of the things that we wanted to look at was we wanted to look at a couple of combination effects. There was some folks down there using some Journey. Journey is a prepackaged mixture of glyphosate plus Imazapyr, which is Plateau, and they were showing good results. So we had never seen this, so we went ahead and tried the standard rate of Journey, which is that mixture of glyphosate and Plateau, or Imazapyr, the active ingredient. We wanted to look at Plateau alone. We looked at a different combination of Plateau and glyphosate, adjusting the rates a little bit to give us a little bit more glyphosate. We also looked at combinations of arsenal plus glyphosate. We looked at ClearCast, which is a Imazapyr, which is a new material that's been labeled for use in natural areas that gives us some Chinese tallow control and some other species, so we wanted to try it on Cogan. And then, of course, we did our standards with glyphosate at our max rate and arsenal at our highest rate. If we go all the way over here to 12 months, we can see that Journey alone only provided about 26% control. Plateau, almost nothing. If we go with a 24-ounce rate of Plateau, which is actually double the labeled rate, we're only looking at about 50%. But if we look at the combination of Plateau and glyphosate, 80% control, which is not too bad. It was much unexpected for us. Of course, arsenal plus glyphosate, it did a good job. ClearCast, pretty much nothing. Glyphosate, decent. And once again, our highest level of control was achieved with arsenal. So a couple of take-home messages from this. One, arsenal, of course, continues to be the best product. But we're seeing halfway decent results from Plateau plus glyphosate. And the reason we were looking at Plateau plus glyphosate, a little less soil activity, maybe allowing some recruitment of native species to come back a little bit better. The next one we looked at was there is a couple of products out there that are supposed to provide enhanced control of glyphosate. It's kind of a tank mix partner to give you a little bit better control of Cogongrass when you use lower rates of glyphosate and or arsenal. And of course, arsenal is Imazapyr, sorry about that, Imazapyr, which is the one we've been using forever. So if we look at Cogongrass alone, of course, 12 months, nothing. Glyphosate at a 1 quart rate, 6%. Glyphosate at a very high rate is 78%. If we added Cogongrass to the low rate of glyphosate, remember it was supposed to improve control. It didn't really improve control, so 6 versus 23, not enough to worry about. If we look at Cogongrass plus the higher rate, we actually went down. It was 78 without Cogongrass, and with Cogongrass down to 67. If we add it to the high rate of arsenal, nothing. If we look at arsenal and some different surfactant mixtures, we look at the methylated seed oil, your MSO, at 1% and 2%. Really no difference than just using a standard non-ionic surfactant. So once again, arsenal at the 32-ounce rate, this was the concentrated, so it ended up being a pound active. Once again, provides us our best control. No additional benefit to having Cogongrass as a tank mix partner, and no advantage of having a different type of surfactant compared to just our standard non-ionic surfactant. The next thing we did was we looked at some new products containing aminocyclopyrrochlor. Now, some initial studies had shown that there was some stunning that was occurring with aminocyclopyrrochlor, which was trade name, believe is Method, that's out there now. I think it's available from Bayer. There were some folks that looked at it over in Alabama that thought they were getting some suppression, some good control with it. So we wanted to try it. Unfortunately, the only commercial, at the time, the only commercial formulations that included aminocyclopyrrochlor were tank mix partners with other products. So we looked at Streamline, we looked at Viewpoint, Perspective. We also looked at aminocyclopyrrochlor alone plus glyphosate. Then we added glyphosate to the mix, and we also compared it to just standard glyphosate and Imazapyr. One of the things that you'll look, if we go at 12 months after, Streamline, almost basically it was aminocyclopyrrochlor alone with Escort, no control. Viewpoint is the only one that has Imazapyr in it, and we can see 73% control. Perspective, not very much. Glyphosate with any of these products, with the exception of Viewpoint, which is 90%. and then we go to 81% with Imazapyr all the way to the bottom. So if we look at our three highest treatments, Imazapyr at 81, Viewpoint, which contains Imazapyr at 90, Viewpoint alone, which contains Imazapyr, 73. So imidacloprid is not going to be an option for us with respect to Cogongrass control. We're still relying once again on glyphosate and Imazapyr. The other thing we did is we revisited the application of Imazapyr, which is Plateau, with glyphosate. We looked at a 2x rate once again, and then we looked at some other products with Plateau or Imazapyr, glufosinate being one, fluazafop being the other. And the only real amount of control we're seeing is right here with Imazapyr and Imazapyr. So once again, Imazapyr is needed to give us appreciable amount of Cogongrass control. The next study I'll talk to you a little bit about is an area that down at central Florida, between Lakeland and Bartow, and it's an old mining area. And this land was abandoned for about 20 years, and for about 20 years there was a very heavy stand of Cogongrass in this particular situation. The site we treated 2 times in the fall and then again in the spring, and then we went ahead and basically saw isolated patches of Cogongrass, probably about 99% Cogongrass control with a few random patches dispersed throughout the field. This occurred in the fall of 2007. So what we did is we took this opportunity where we had almost complete Cogongrass control with a few stragglers here and there, and we set up revegetation schemes throughout this area right next to a patch. So we'd take a small patch of Cogongrass and we would plant a suite of native species, 3 different types of native species arrangements, and then we just watched it to see if the native species could hold their own, what would happen to the Cogongrass, and then we also went in there and at 9 and 21 months after we planted, we sprayed the Cogongrass that was trying to invade or starting to regrow next to one of our revegetation native species patches. And this will come a little bit clearer once I talk to you with some more pictures. So this is basically what we're looking at. If we look, this is our center post. We have all of our native species planted in a circle around this center post. It was about a 12-foot diameter circle, and it was planted right up next to a patch of Cogongrass right here. So we had wiregrass, we had andropogons, we had some pityopsis, we had mixtures of different species, native species that were native to that area, and once again we planted them right up next to a patch of Cogongrass that was just starting to come back from those previous treatments. So we rated over a period of time. At 40 months, we went out and did a very aggressive visual rating, and what we saw is we had our 3 different mixtures. We had where we planted only grasses in our native species mix. We did a mixture of grasses and forbs, and then we had something where we just allowed Mother Nature to come back in. We didn't plant anything. We just allowed Mother Nature to try to recruit. One of the things that I'll mention is the grasses and the forbs. These were all transplants, so these were plants that had been had a very well-established root system. So it wasn't from seed; it was actual transplants that we put in the ground. If we look at where we had no supplemental glyphosate, so where we didn't go back and try to spray the Cogon patch next to it, and we look at the percentage of native species versus the percentage of Cogongrass, in the grass-only mix, and this is only within that 12-foot circle that was planted, we see about 62% of them were native species, but there was about 38% of that patch was Cogongrass. If we look at the grass-forb mix, we still see a little bit more native species, a little less Cogongrass. If we go where we didn't plant anything, only 12% native species and a lot more Cogon coming in. So what it tells us is that the grass-forb mixture gives us a little bit better suppression of Cogon, It also tells us that native species recruitment on its own without any help was much less effective in keeping Cogongrass out. Now if we go down to our glyphosate, where we supplemented, we actually sprayed that patch that was trying to come into the native species circle, we see more native species in the grass only, much more in the grass form, a lot less Cogongrass, and we did see a little bit of benefit where we saw our native species complex all by itself, or just natural recruitment. But the take-home message here is we're seeing some suppression with native species, but we're also seeing a fair amount of Cogongrass coming back in, regardless of whether or not we supplemented our treatments. We went out there again, and we started to see what was happening is the Cogongrass would send a rhizome spear right up into the center of the patch. And it didn't matter what kind of density we had, it didn't matter what kind of composition, whether it was grass alone or grass forward mix, Cogongrass was still coming in. This suggested to us that we have a zero tolerance policy for restoration. So if you're going to go out there and spend a lot of money on restoration, you got to make sure that the Cogon is completely out. 99–98% control is probably not going to be good enough for Cogongrass. And if we go out there 5 years later, we can see these are our individual plots. Almost no native species whatsoever. The Cogongrass has pretty much rebounded from less than 1% coverage to almost 95% coverage back in that area. So it just tells us that if you're going to go after Cogongrass, you better be very aggressive, and you better not allow any of it to be remaining when you want to try, particularly if you're going to try to revegetate with native species. So overall, our best results will include burning, chemical applications of glyphosate and Imazapyr. If you can till it, that works best after your chemical applications. Like I said, burning or mowing before the herbicide might be helpful to get that patch out of the way, allow some regrowth from rhizomes, and tillage following the herbicide seems to work best from the studies that we've done. And this is just a shot here showing a very large patch of Cogongrass, almost 200 acres. This is an abandoned mine site at the Peace River Park down just outside of Bartow, Florida. So now what I'd like to do is change and talk to you a little bit about, finish up this webinar with a few slides talking about seeds and some other issues we have with Cogon. So as I mentioned, we thought it was all came from a clone. However, we're seeing increased reports of seed vector populations. We did some work with some folks in Georgia, and we are seeing seeds. We've documented that. There is some good news with regard to seeds. They have poor seedling vigor. They also don't last very long. So less than a year out in the field is about as long as these seeds will last. At least that's from what our preliminary studies have suggested. So even though it does produce seeds, the ability to get established from seeds is not as good as it is from rhizomes. The other thing is, I mentioned that Cogongrass is all over the world. It's native to Southeast Asia here, but it's also found in East Africa. It's found quite a bit in West Africa. It's found in areas of Chile. It's found in Guyana and along this Guyana Shield here, of course, in the southeastern United States, but it's also found in the Mediterranean. So there were some studies years ago that tried to group Cogongrass infestations by its variety, Major, Europa, Africana. There's also a similar variety or species, Braziliensis. So why does all that matter if we're trying to control it? Well, the reason that it was set up in varieties is there's another variety over here called variety rubra. Variety rubra is a commercial variety. That variety is sold as an ornamental. It is sold because of the unique color of the above ground leaves. We can see purpling, this bright, brilliant red color here. then it's sold as a commercial biotype because of the fact that it's considered to be a unique variety. However, if you take this species and you plant this variety in the greenhouse, it will revert back to the green. The other thing you'll find is aggressiveness appears to be conflicting. Some folks will say it's very aggressive, other folks will say it's not very, very aggressive at all. The big issue is the fact that it's cold tolerant. These plantings are established and survive in Idaho, in Michigan, in Maryland, in the upper Midwest. So regardless of why it's being used and its aggressiveness, the fact that it's cold tolerant is one of those things that really makes us begin to wonder and causes us a little bit of issue with respect to how we're going to manage this. We've also thought, well, maybe it's Imperata brasiliensis. Maybe it's a strain of that and not really cylindrica or Cogongrass. So it's a red variety. It's sold throughout the ornamental trade. It's under the trade names of red baron, Japanese bloodgrass. You can get on the internet and you can find this very, very readily. However, one of the things that we were able to do a couple of years ago is we took pollen from a red baron population growing in a garden in Maryland. We took some wild Cogongrass that was growing here in Alachua County just outside of Gainesville, and we produced a viable cross between the two, which means that red baron can cross with regular Cogon, and we don't know, but is a possibility that we could be transferring cold tolerance from the red baron into wild Cogon, creating an aggressive cold tolerant population that would have the ability to move further north than what we currently think. So where do we go from here? Well, I think we're doing a really good job of managing those target populations. I think you guys out there are doing a really good job at targeting those outliers. We're still relying on glyphosate and Imazapyr. There's nothing new in 40 years. Our seed viability and spread is concerning. We could see some population shifts, more rapid expansion, and the threat of resistance whenever we see sexual recombination. Well, we'd like to talk a little bit about some research to date, where our genetic analysis shows that we've got multiple introductions. We're rapidly changing flowering times. We're seeing a fair amount of genetic diversity, which basically says we're seeing some hybridization. And Brazilian satintail, even though it's out there and has been implicated, really isn't a major player in this game. So, questions we've got confusion, non-viability, but how do we know, and how much diversity do we have? So I'll go ahead and stop there and try to answer
a couple
of questions.
Thank you, Greg. Great webinar. We've got several questions that have come in from the crowd here, so let's get right to them. Greg, can you define what you mean by outlier populations and outlier states? What we're talking about here are those isolated populations that just kind of crop up without being located next to a patch. So let's say you could go 40, 50 miles away and all of a sudden there's a small patch of Cogongrass that comes up. And the reason that we talk about outlier populations is when you look at a giant, huge amount of Cogongrass, you want to get the edges, so those outliers first, and then walk your way back in towards the major infestations. And could you tell us which USDA agency introduced this as a possible forage crop? And then as a follow-up, the quote here, why on earth would they think it would make a good forage crop? Okay. It was introduced by USDA ARS, or basically their Plant Introduction Service. One of the reasons that they thought it would be a good forage crop is the fact that it could persist. And one of the issues we have in the southeast is the fact that we've got droughty conditions, we've got poor soils. So a forage that would maintain itself in fairly poor conditions and continue to put on leaf biomass was something that they were looking for. Unfortunately, the leaf biomass that it does put out has very poor nutritive quality. It also has the ability to accumulate silica. It's hard to eat for the cattle. So
They were looking at the fact from its persistence, and then realized once they got it over here that the forage quality wasn't all that good.
Right, and back then we had that plant introduction group, and they also brought kudzu in for erosion control in the 20s or 30s. I think it may have been used as a forage crop also, but I guess it's important for people to remember that back then we had different knowledge and different technology, and bringing plants in was somewhat common because we thought we could use them for certain things. On to another question. Does crown closure shade from, say, loblolly reduce cogongrass or stress it?
That's a good question. I think if you had a thick stand of loblolly and then cogongrass was introduced somehow through a disturbance event, either through or came in there from seed, I don't think cogongrass would be that aggressive underneath a shaded canopy. Where we see cogongrass coming in and being aggressive is where you have an established stand of cogongrass, it's tilled, and then you plant pines into that tilled area, or you have an area where there's some cogongrass underneath not doing a lot, and then you go ahead and cross thin or do some other kind of disturbance to open the light up. So once it's there, it's hard to compete out, but if you have dense shade, it doesn't like to go into completely dense shade from an outside. Okay.
And glyphosate and Imazapyr have different modes of action. Is there a recommendation to alternate these chemicals?
From a resistance management standpoint, I think anytime you could mix up chemistries, that's good. However, I think from a management standpoint, I always like to go with Imazapyr if I can, and then I follow it up with glyphosate the second time around. The reason is that Imazapyr gives me more bang for my buck the first go around, provides that soil residual activity to knock that any regrowing shoots back down again. When I see the Cogan starting to rebound, then I hit it with glyphosate. The reason that is because glyphosate doesn't have the soil activity and allows any native species that might be in the soil to come back up through, and gives that Cogan grass a little bit more to work against from that standpoint.
And have you seen resistance to any of these herbicides or any other herbicides?
To this point, we have not had any reports or noticed any resistance from glyphosate or Imazapyr on Cogongrass. We're very, very concerned. We're very vigilant. We really, really need to know if this is a possibility. There's other products out there that don't work as good. That sometimes they work good, sometimes they don't. But that's not termed resistance from what we're talking about.
Okay. On the Journey plus Plateau study, can you tell us what type of light level was used?
Yes, the light level for those studies that were done at the Cheeto branch site was all full sun.
Okay. When you talk about acres, are you counting what you see across the surface, or are you adding surface plus below ground?
No, we're just looking at surface acres.
And another question, alternating herbicides and herbicide combination study. What about cefoxidim or Assure or Scepter? Have you tried those?
Cefoxidim, we've done some work years ago that of the grass control materials, we chose fluazepop because that has the strongest amount of activity. Cefoxidim has almost none. Assure has very, very little as well. Scepter, which is older chemistry, very similar to Imazapyr. I think it's Imazaquin, which was one of the first of that class of chemistries that were introduced. We have not tried that, but to my knowledge, I don't think it has a natural areas label, or a non-cropland label. And Imazapyr has the same similar mode of action, so that's the one that we've always utilized in our studies.
And have you used any surfactants or adjuvants when you spray these chemicals?
Yes.
Or do you go strictly by label rates and that type of thing?
Correct. Yes, we whatever the label suggests, but we have tried different surfactant mixtures. We always use a non-ionic surfactant with any of the materials, and that includes glyphosate as well. So we've looked at some other ones, but we always use a non-ionic surfactant.
And the last question we have, is this a viable grass for recovering post-mining areas, soils, removing heavy metal or toxic conditions? I'll just interject and say you should probably never plant this grass anywhere ever, but I'll let you address it as well.
Okay. Well, one, it's on the federal noxious weed list, and I believe it's on all the state noxious weed lists, so it's prohibited from planting. From a reclaimed mine standpoint, Cogongrass probably on our older mine areas in Florida where we've mined phosphate. If you mention that to any of those folks, they're going to get very upset because of the fact that once it gets in there, a lot of mine areas are required to put it back in some sort of a reclamation standpoint, and an invasive species like Cogon is not considered to be an acceptable reclamation strategy. From the standpoint of pulling heavy metals out, I haven't looked at that. There's a possibility. Where we've seen the most heavy metal accumulation has been actually through ferns, not so much Cogon grass. Grasses in general, I'm not sure of their ability to take up heavy metals.
All right, that's the end of our questions. Thank you, Dr. McDonald, for helping us out today and giving us this great information on Cogongrass. And thanks again. We appreciate it.
Thank you.